Hello everyone, my name is Oscar Reyes and I'm a lead software engineer here at Tracetest. Today I'm really excited to show you the latest integration that we have that is between Tracetest and Artillery that can be used to enhance your performance testings with trace-based tests using our latest plugin. So with this in mind, let's move on and see what we're going to be testing today. So as you might have seen in the previous examples, we're going to be using our always reliable Pokeshop Demo, which is a fully instrumented Node.js service. It's fully distributed, and in this case, we're going to be looking at the Pokemon import process. The import Pokemon process is a two-step section, which includes an initial request to the post Pokemon import API, and then it validates the requests to then put a message into RabbitMQ. And then the second half is grabbing that message from the queue and importing the Pokemon by triggering an external request and saving the data to the to Redis and Postgres. That is just pretty much our backend data stores. As you can see, we also have some telemetry data from Artillery that we're going to be looking at as well. So yeah, let's buckle up and start with this plugin explanation. So the first thing that I want to do is I'm going to show you the test script for Artillery, and I'm going to removing these plugins for a second so we can take a look afterwards. I'm going to be triggering an HTTP request to this endpoint that is the Pokeshop URL, and it's going to be a post to the Pokemon slash import service with the Pokemon ID of 100. This is going to trigger the asynchronous process, and it's going to get me the information of the Pokemon afterwards. So if we go to our terminal and execute this by running the npm run test plugin command, we will be able to see the response from Artillery. As you can see, everything looks correct. The status code is 200. The response time is good. We can see our min, max, P95, P99 reports. So everything looks correct, nothing wrong. But what if I told you that this process is actually breaking or is not complete? Because if we go to our Docker setup, we can see that the worker is offline. So the worker is actually not enabled and it's not processing the requests. This is a limitation with the performance tools, that they only have visibility of their initial request and response, and it is hard to understand what is going on or what is happening in the back side of things. So if we go back to our testing script and we remove these comments, and let me explain you a little bit what's going on here. We're using Artillery's own plugin for publishing metrics, and it's configured to sending the telemetry data from the Artillery binary library to the hotel collector. It's going to be receiving both metrics and traces, and it's going to enable us to see what is actually happening within Artillery. And the second plugin that we're going to be adding is the Tracetest one, which requires a token that you can grab from your environment in the Tracetest app. And then we also have the definition file that we're going to be using for these tests. That is a file that is within the same directory and pretty much has the information about the specs that we're going to be executing, as well as an output from the test. If we look deeper into the specs, we're validating that all HTTP spans return at 200, and we're expecting the database to be fast, and the operations run are less than one second. And then we're also validating one of the spans generated by the Artillery telemetry data, which is the response in time in milliseconds, and we want this to be less than 100 milliseconds, so we know the initial record response is fast enough. So if we go back and we have all of this already established, we have our reporter, our published metrics and trace test, we are ready to execute this again. So we can go back and see it and run it again with the same command. All of this code is part of the example that you can find in the documentation, or as well as a link to the repo. You can run it yourself. It's available for anyone to use. And yeah, it's part of this example of this video as well. So this now is going to take a little bit longer because it's waiting for a trace-based test to finish, not only the ones from the from Artillery. And as we can see, now this is failing. And why this is failing? Well, we have a summary exactly of what is going on, so you can see from yourself from the CLI response what is happening. But the interesting part is that you can also follow the link as part of the output and see. I have a more visual kind of visual way of investigating the spans and the specs in the UI. So as you can see, we have the artillery telemetry data where we have the posts, and the post actually has an spec that is passing, this is returning in less than 100 milliseconds, so this is good. But then we are missing the second half still. We don't see the worker, we don't see the work spans, everything around here is missing, and it's because our work is still offline. So all of the specs that are tied to those spans that are happening in the second half are missing. How we can validate that? So we can go back to our Docker setup, actually putting the worker online now, and then I'm going to just switch the Pokemon ID to 101. So now what we can do is going to be triggering the same script to run the artillery test setup now with the worker that is online. It is going to take, we're expecting the same response time where we're running the trace-based test as well. So we were expecting Tracetest to gather all of the telemetry data generated from both the artillery library and also the backend services. And as the difference is that we expect the summary to be all green and that the test is running as expected with everything looking correct. As we can see, the summary now only shows the green status, that everything is looking as expected. We can follow the link to the Tracetest app UI, and we can find and we can see all of the spans are also all of the specs are green. So if we click in some of them, we can see the spans that are matching and the validations they are doing. The status code equals 200, or that the actual Pokemon that is being triggered, it's used in the request. So we're using Pokemon 102, and this matches with specific response and the route that is being used. So all of that is working as expected. Just to a quick summary, what we are seeing here is that we can enhance our performance tests by including trace-based tests. So we can have a deeper look in what is happening in the backend system. Then we can now rely on the telemetry data to add test specs and the validations after that by using the Tracetest plugin alongside Artillery. So in this case, you are not only relying on the initial request and response, but you have more visibility what is happening. So yeah, thank you for watching and see you next time. Bye.